All right, let's do the exciting second part of this, okay? I hope this is, pretty exciting for you guys. All right, so run this blah, 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 set it to that, 2 seconds, and 0.2. Set the period, and let it run for 100 seconds. All right, so I'm going to run. And we've seen this graph before. Okay, I got another joke for you. You ready for this? So, Alabama plays Harvard in football. You got a picture, okay? And this guy from Alabama sees this woman, sitting in the Harvard section. And he just wants to strike up a conversation with her. So he says, what school do you go to? And to which the young woman replies, Yale. So he says, what school do you go to? Okay, anyway, I can't really tell if you got it. All right. I think we can start answering these questions, right? Okay, so what is happening to the velocity of the oscillator as the amplitude increases? Why does it increase? Why does that happen to it, right? You know that if the amplitude increases, right, that what the maximum velocity is what? It's omega x naught. So if x naught gets bigger and omega stays the same, then it seems like the velocity does get bigger, right? What's happening to the damping force as the amplitude increases? Well, the damping force is some constant multiplied by the velocity. So think about what happens to the velocity, okay? And if the damping force is some number multiplied by that, whatever happens to the velocity also happens to the damping force, okay? What is happening to the rate at which the system dissipates energy as the amplitude increases? Well, if the force is bigger, maybe, right, then it seems like we're exerting a bigger force, so we're doing more work per cycle. So it seems like we're dissipating energy more quickly, right? Okay, so compare the rate that the system receives energy to the rate at which it dissipates energy. Well, from 0 to 40 seconds, right, the amplitude's increasing, so it must be receiving energy faster than it gets rid of it. And from 40 to 100 seconds, it seems to be more or less in equilibrium, right? Okay, so it's dissipating energy at the same rate that it gets it. Okay, that's what's going on here. I'm sorry that you can't sit here and mess with this. Well, there it is. All right.